this one, same directions. Since this is a polynomial, that means it's going to be continuous and differentiable, so we can apply the mean value theorem on this interval. To do that, we need to find out when the derivative is equal to f of b minus f of a. So our derivative here is 15x to the fourth plus 15x squared plus 15. We want to know when is that equal to f of b, so f of 1 minus f of negative 1 all over 1 minus negative 1. So 15x to the fourth plus 15x squared plus 15 equals f of 1. If we put 1 into this function, we're going to get 3 plus 5 plus 15, so 23, minus f of negative 1. If we put negative 1 in there, we're going to get negative 3, negative 5, and negative 15. So we get minus negative 23, which becomes plus 23, all over 2. So 15x to the fourth plus 15x squared plus 15 would equal 46 divided by 2, which is just 23. We want to get everything on one side here, so we can try and factor 15x to the fourth plus 15x squared minus 8 equals 0. Now, to solve this one, we could try and factor this into two binomials, where we have 3x squared and 5x squared, or 15x squared and 1x squared. But in this case, it doesn't really work out. We can't find any values that multiply to give us negative 8 and make this work out to get our middle function. So an option other than this is to go ahead and graph this function. So if we use our calculator and go to y1, type in this right here, and look at our graph, we have what looks kind of like a parabola, and it has two zeros. Right? We want to find out when is this function equal to 0. So we're calculating zeros, which we did on the last chapter on that quiz in 2728. So to do that, remember we're going to do second trace. We're calculating a 0. So we need to pick a point to the left of the 0. So the left side of that 0 is going to be a positive value. So it looks like this is 1 here, and it's to the right of 1. So I could type in 1 for our left bound, and you can check. It says 122, so we know it's going to be on the positive. It's going to be up here somewhere. Now it's asking for a right bound, so we need a point to the right of the 0, and 0 is to the right of that. So we're going to hit 0, enter, and it says guess. I'm going to hit enter one more time, and I made a mistake. Let's try that again. So second trace, 0, left bound, and do negative 1. I think I typed in positive 1. And right bound, 0, guess. There we go. Our 0 is negative 0.6205. So that's one x value, falls in between negative 1 and 1. And then for our next one, do the same thing here, second trace, 0. This time our left bound, I'm going to use 0 because it's the left of this point. Enter. Right bound, positive 1. Enter. And guess. And we get positive 0.6205. So those are our two values where the instantaneous rate of change is the same as the average rate of change.